Okay, now, two things. And what do pay attention to this. About half of you have the basic exponential function, the other half are doing something else. That's okay. Draw whatever graph you have and make the estimates, and I'm happy to see the estimates, okay? If you don't know how to put the estimates together into calculating your rate of change, I've reminded you, and I won't ordinarily remind you about something you really should take out as the primary idea in an assignment. I mean, I'll remind you, but probably not during the quiz, okay? And I'll repeat it, you know, because it deserves to be repeated a lot. Fundamental concept of calculus, and an important concept in pre-calculus in its own right is the rate at which things change. And it's a change in one thing divided by a change in the other. That's it. In this case, we simplify it, change in y divided by change in x. Okay. So is whatever graph you have, make your estimates and give me the rate of change on this interval. I fear that there's a tendency to do the homework by following the steps in the video without thinking about what they mean. It's not going to get you through this course. It is very close to what you need to do to get through the course. It's fine to do that, as I've said again and again, probably in this course, at least once in this course. You need to go back through the assignment and rework it without looking at your work or the videos. So you really focus and think about what things mean. You got to get to the deeper meanings or you won't be able to apply what comes in. Okay. So go on. I'm happy to see graphs. I'm happy to see the estimates you're doing. I'll be even happier if you can translate that into a rate of change. Okay, now the missing piece really was this. And if you came into class not knowing this, take a lesson, because you knew what to do as soon as I wrote this down. I think everybody did it right. So I'm pleased with that. But remember, when you do a quiz, first place, that's supposed to look at your notes. Now, right now, if you're making an effort on the quiz, I kind of give you full credit for the quiz. Start next week, I'm going to start grading. And when I start grading them, no notes. Come in, prepared, do whatever's necessary. I do advise that you don't start the assignment an hour before it's due. Sometimes they take longer, sometimes they don't. I would start the assignment this evening. Now, life might not allow you to do that, but if you start it, even if you only spend 20 minutes on it, maybe reviewing your notes, maybe reviewing what we did in class, refreshing your memory, then your brain will work on it while you sleep, and whatever else you got to be doing for the rest. Okay? So as soon as possible after class, you pretty much want to review your notes, or you want to take a look at the text, or you want to take a look at the problems. And, okay, it looks like I can do these. But don't wait until the last minute to do them because you forget what's done in class. Okay, at least take time each day to remind yourself of what's been done. It's only 10 minutes. 10-minute glance at your notes. Try to make notes that focus on the high points, focus on the things you really need to understand, things that you're not sure you're going to remember. Okay? If you do those things, you're going to do much better in the course. I think everybody's going to do okay because everybody seems to be doing their work. And everybody seems to have the aptitude. We'll see how your algebra is. That's something really shaky, but we'll fix that if we can. Okay. Okay, so first place, if you don't know what the basic exponential graph is, don't know how to do the arithmetic, you're way behind on these functions. As I said at the very beginning, first important thing you do in class is know these functions. You did an assignment where you're asked to identify the functions and stuff, but you might have had a table sitting there and just copied down whatever said in the table without understanding it. You have to know these functions. And I won't talk about the 5 that I emphasize. The rest of them, I don't care if you go to Chegg and ask, what's that function again? You don't need to because it's right there in your open math. Okay. And if you use them enough, you'll understand. If you understand the 5, you get all the important behaviors of all the others, pretty much. And you got step functions and stuff, and absolute value functions. They're pretty simple. Okay. Okay, so basic exponential function. I'm not going to do that for you. Okay, we've done it. But your basic exponential, I'm going to do that here, and I can make a reasonable size graph. Okay, so here's 2, here's 1, here's 1/2. And we don't really want to work out. And up here we got 4. Down here we've got 2. So we subdivide. And we sketch the graph. I'm not going to sketch a lot of stuff here. But over here, let's place. Over here in the region where we're going to do estimates. And sketch. Now I've got something where I can do estimates. I know what these numbers mean because I'm familiar with these graphs. I've worked with them. I understand them. I understand the arithmetic that you need to evaluate the functions, and I'm going to do it right. And you need to be able to do the same thing because I'm often going to ask you to sketch a graph of a square function, exponential function. You need to know what the names mean. You need to know what the formula is. You need to know how to make the table. You need to know how to sketch the graph. Okay, and quickly. So if you're rusty on that, get the rust out. Okay. So anyhow. Well, here's one. So I'm going to say 1.4 is about here. Now here's 2. Well, here's 3. So 2 point, and that's not. Yeah, it's not too bad. So 2.6 is over here. So estimate y value for x equals 1.4. Okay. Y is approximately 2. Now this is 2. And halfway is 3. I'm going to say it's about 2.6. Now that's not a really good estimate. I know, well, actually, yeah, probably it's just not one. It's 1.5 to 2.8. So it's probably not bad at all. I probably lucked out and made a good estimate. I don't care if your estimate's great, as long as it's reasonable. Okay, now 2.6, as I said, I kind of threw you a curveball. It kind of goes on up here. So to get the value for 2.6, I don't know. Extend the y-axis. This is 4. This would be 8. I'm going to say it's about 7. I'll put question marks there because the way I had to fudge the graph. Okay. Because I give you a number that's kind of out of the range. Okay, just do what makes sense. I do something stupid, make sense of it. Okay. Do some an oversight, make sense of it. Okay. Yeah, don't just take the attitude, well, I know you made a mistake there, so I don't have to do this. You don't learn much by doing that. Or I know you made a mistake there, so you're not going to penalize me, so I'm going to blow that off. You don't have any choice. If it's a bad mistake, you might not have a clue what to do. In this case, extend the graph. Okay. If you don't, well, again, I'm not going to penalize you. I'm drawing a line segment from here to here, just to indicate where the estimate starts and where it stops. And again, I'm drawing it so I can draw a triangle here. And here to here is the change in x. From here to here is the change in Y. Okay. Then I can write the coordinates of the points. That's always a good thing to do. Most of you did that, and that's always a good thing to do. So I'm glad you did. So I got 1.42.6, and up here, coincidentally, that came out 2.6 and 2.6 was one of my X was taken down. So up here we've got 2.67. Well, which might change in X. It's 1.2. I think a couple of you got 1.2. So you got the same estimate I did. I don't know if that's good or bad, but you got it. Okay. But it is 1.2. I forget very much about that. Once I wrote down what the average rate of change means, plus I didn't have it. So I went down. Okay. Delta Y is going to be 7 minus 2.6. That equals 5.4. So the average rate of change the interval 1.42.6 is change in Y over change in X. I'm using the delta because I don't have room to write out change in because I didn't leave myself enough room. Okay, bad planning. And when I say delta Y equals, I'm going to use a way to equal signs because it's an approximation based on an estimate. Okay, now delta Y over delta X is 5.4 over 1.2. And that's 4.5. Now, most of you got lower estimates because you probably didn't leave yourself room to extend the graph. Okay. And I don't know if my curve is any better than yours. Most of you got lower estimates. That's okay. Had you given your points within the range, you probably would have done it better. Yeah, I got a result closer to the one that I would get. But I don't know if my estimate's better or yours is. Those are our estimates. Okay, understand that process. Now, do you understand how you could write that out coherently to really show yourself what you're doing, to reinforce what you're doing? If you draw the picture, write out the definition, and write it out really coherently like I do on your paper. You know, I never know what I'm going to end up writing out because it depends on what I see in the papers. That's my excuse for being a bad organizer. Word space. You don't need an excuse. But try to organize. The central thing is this picture. Everything else is kind of peripheral to the picture. If you got this picture, then you understand the picture way better than you understand a bunch of silly formulas. That formula is not silly, it's a good formula. But there's a meaning to the formula and it's revealed by this picture. Okay. So there's your idea of average rate of change. If you got that much at this point, you're pretty much doing okay. Now there are a few applied problems, which says a rate of change of your distance with respect to time or whatever. You want to do okay with those. We'll maybe talk about that a little more. But except for not remembering how to find a rate of change, or the definition of the rate of change, you did real well. Okay. Now, of course, the most important thing is the definition. So take a lesson. Okay, as I said, rate of change composite functions, transformations. In my not so humble opinion, three central core ideas that you really want to understand that really kind of get in your way in this course and later in a calculus course if you don't develop a good understanding. So composite functions. I'm just going to do an example. I'm going to ask you to, okay, well, first of all, let's let f of x equal 2 to the x, your basic exponential function. And let g of x equal 1 over x. Okay. Give me the simplest possible expression for f of 2, for f of a plus b, for f of r bar, and for f of g of x. I mean, the simplest thing you can write down without doing any calculations or algebra or anything, okay? And what I'm talking about is if you replace x by something, you've got to replace this x by the same thing. And that's all I'm asking. Whatever x is replaced by, put it here. Okay. The one step is very, very simple. It's just 2 to the second. Everybody got that. It's not 4, it's 2 to the second, then it's 4. Okay? Because we want to look at the simplest thing, because there's a strong tendency of people when they do composites to get a little confused about what they're looking at and not just write down the simple thing. Okay, so the simple thing here is this. The simple thing here is 2 to the a plus b. And if you want, you can put parentheses around that. As long as it's clear it's in the exponent, parentheses aren't necessary. But if they clarify things, so they're not necessarily a bad idea at all. Okay. Either way is okay. Parentheses is probably better for right now. This would be 2 to the r bar. I don't know how you raise 2 to an r bar. I'm just not that familiar with r bars. Okay. And then f of g of x is 2 to the g of x. You can write these down mindlessly. And that's what you want to do when you see function notation. Write it out mindlessly, then deal with it. Don't start dealing with it until you've done the mindless thing first. You're replacing x by something. Okay. Now, we can go ahead and write another step on some of these. 2 squared is 4. 2 to the a plus b. Well, you know the laws of exponents. It's 2 to the a times 2 to the b. But usually we consider this a simpler expression. Sometimes we want to do this. So you have to understand laws of exponents. We've dealt with them. Make sure you understand them, review them frequently, and make sure you don't misuse them. Okay, now, what are we going to do with 2 to the g of x? Go ahead and write out the next step. Many of you, of course, skipped already to the next step, which is not bad. But be mindless before you do anything. Okay. And what's the next obvious step? Okay, so everybody. It's 2 to the 1 over X. Okay. Well, that's nice. So that's your first hurdle with composite functions. Again, do the mindless thing. And then expand it or simplify it or whatever. Okay. So okay. Inside the yellow boundary is the mindless thing. And then we have some simplifications. And I would call these simplifications and or expansions. Okay. And I consider this something like an expansion. Not really simpler than this, because it's actually simpler than this. But that's certainly of this, there's various things you call these. You kind of extended this substitutions. Very good. Okay. One thing you're going to see in your homework is correct. So what I'm going to ask you to do is just to revise the basic functions again. That says reciprocal. That's me. F G of 2 such. How long perhaps if you're forwarding, if you can use them for reference or quick calculations. Okay. Right there's part of the graph of the basic exponential function. And over here. It's not a great graph. And you're 1 over X function. Have a good day. Reciprocal function. curve about like this. Now, if you really wanted to use the graphs to do this, and you had good graph paper and could draw really precise curves and draw nice perpendicular projection lines, you could come up with pretty good estimates. In this case, even if they're a little sloppy, I'll take any estimate that's halfway reasonable, okay? So just make estimates and see if you can use these graphs to estimate f of g of 2/3. Again, some people do it stuck after you get the graphs, what to do with that 2/3. Well, that 2/3 feeds into the g function, doesn't it? And which graph is the g function? Well, it's f of g of x, and we're using the same f of g of x, right? G of x is your 1 over x function. They can easily calculate g of 2/3, but we want to use the graph to estimate it. Okay. So we're going to want to feed the 2/3 into this graph. And we're going to get a number. And then hopefully figure out what to do with that number. And if not, I'll tell you in a few minutes. Okay, so how are we going to get f of g of 2/3? Well, here's our graph of y equals f of x versus x. And here's our graph of y equals g of x versus x. So you really want to label your graphs differently, so you know which graph is which, and writing y equals g of x. And if you want, go ahead and write that, okay, 1 over x. That's a very probably good idea. And write that this is 2 to the x. So now we're doing f of g of 2/3. Well, we want to find the value of f. But first, we got to find the value of g of 2/3. We don't know what this number is. Once we know what this number is, we can use the graph of f of x to get it. So here's your graph of g of x. We want to find g of 2/3, so we find 2/3 of the graph. So there's 2/3, and everybody knows that you get real good at this. Okay. So I'm going to make a bad estimate here. I'm going to say that's about 1.3. My projection line went a little bit to the right, so I'm getting a little bit of a low estimate here. Should have appeared close to this. Pretend at 1.3. And I can even write, and if you really want to write everything you can that helps you see what the picture is, so we could write that's a 2/3 there. Let's see. G of 2/3 is approximately 1.3. Okay. Now we kind of know better because if x is 2/3, 1 over x is 3/2, which is 1.5. 1.5. So I'm kind of off with that estimate. Remember, I told you not to do any calculations. So we ignored me. That's all right. But you do that with caution. Because as I said on your homework, you're going to have graphs where you have to make estimates and you don't have a formula. It's not one of your basic functions. Okay. Okay, so anyhow, there we have this. Okay, so over here. So, okay, by our estimate. I can replace g of 2/3 by the estimate 1.3. Now we want to find f of 1.3. How do we do that? Well, that's straightforward. Find 1.3 here. And we project up here. And we project over. And that's 2, that's 3. I'm saying that's maybe 2.4. But maybe it's 2.3. I don't expect it's going to be particularly accurate because I'm off here. And being off here throws me off even further over here. Okay. But it's okay. And so that's approximately equal to 2.4. Okay. Well, most of you have calculators, phone app or whatever. So let's see if we can calculate this. You're going to need the calculator for the exponential function. You don't really need the calculator to evaluate g of x, and a lot of you went ahead and did that. So I won't say you're vindicated or anything, but it'll be useful if you did it, but it's easy. Okay, so okay, what is g of 2/3? G of 2/3 is 1 over 2/3, because g of x is 1 over x. So we just plug 2/3 into the g of x function. We get 1 over 2/3. Is reminded since g of x is 1 over x. Okay. Which is, of course, then we simplify this, f of 3/2. And then we're going to write this as a decimal because of what's coming. What's f of 1.5? It's 2 to the 1.5 power. Since f of x equals 2 to the x. Now take your calculator and see what you get. If you do 2 raised to the 1.5 power. I assume you know how to raise something to power using your calculator, but if you don't, just come around. And what are you supposed to do here? And I'll probably confuse you because I don't know how your calculator works. But oops. There was my arrow down the gas. You're gonna get 2.828 and then some stuff. Okay, 2 times square root of 2. What you got? Okay, now how close was your estimate? Mine wasn't particularly good. I got 2.4. I should have got like 2.8. Whatever. I think y'all know how to use your calculator. Okay. Is that close to your estimate? In many cases it is. You can't even get it. Well, make 2.8. Yeah. Well, let's see. The G of 2/3 is 1.75. And 1.75 here. Of course, it's not here. The 2 would be about here. So might have 3 points. Wouldn't have been too much further from what it is. It's going to agree with a calculator or a computer. Anyhow, I said it a little more slowly, but you get 2.828. Almost everybody had that on their calculator. A couple of people didn't have their calculators handy, but that shows you that the estimating process. Even if you kind of screw up over here by going a little too far to the right on the curve, getting a low value here, still it was 2.4, which is off by about 15% what it should have been. So that's not great. Most of your estimates are closer. So that's good. Y'all did well. And when you do it on graphs, on your homework, I think we're going to find that you do it well there too. Now we could go further. We could, if we have a graphable function that we don't know how to calculate, just a graph, we can make a table. And we could take this function here. That should be a little more horizontal. If there's a function, then we could take, let's say that's 1, 2, 3, 4, 5, 6, 7. And up here is, oh, let's see, 9. Okay, so there's 9, here's 3, here's 6. My scaling isn't great. But I can now make a table. Let's say this is our g of x function. A lot of times you run the table horizontally. Okay, I'm not going to fill in the whole table, but I can make estimates here. I'm going to say for 1, we get about 3.8. I don't have room for both. So I'm going to have to do a little more abbreviated table, but that's okay. See what to do. Done already. Okay, everybody sees what I'm doing, right? Because you know this process. And we'll go back. After watch start 2. So 1, 2, 3, and then for 4, we get. Let's say that's 9. And we can continue the table. Yeah. We can go up a couple more units. Okay. Easy enough. And now let's say we've got an element function. Does this. Okay, well, we can again make estimates. Let's say this is 16, so you've got 8, 4. Well, so now if x is 1, we get a value. If x is 2, we get a value. But we really don't need to estimate values till we get out to about x equals 3. And in fact, let's just go ahead and list the G values here: 3.8, 5.8, 6.5, and 9, because we're going to do f of g of x. So we've got x values, we've got g of x values. Now we're going to feed those x values into f of x and making estimates on this graph. Okay, so if x is, so we said if x is 1, g of x is 3.8. Now if x is 3.8, f of x is what? Well, there's 3.8. Looks like it's about 5. Do you understand what I'm doing? Very similar to what we did with making the table. Okay, we go to 5.8. Well, 5.8 is about here. We go to 5.8, we see that that's a little lower. We'll say that that's about 4.7. Now we go to 6.5. Looks like we might be back to 5. But when we go to 9, then we jump all the way up to 11.5. So what is our graph of f of g of x look like? Here, I'm going to eliminate this line here and label this a little differently. Not going to leave it the way it is, because I guess the way you're going to see it in your book. Okay, so find that out. If x is 1, then g of x is 3.8. So f of g of x is 5. If x is 2, g of x is 5.8, according to the estimate. So f of x may be 4.7. If x is 3, g of x is 6.5. So f of g of x we estimated to be 5. And then if x is 4, g of x is 9. So that f of g of x is about 11.5. Okay. There's another issue that comes up with composite functions. Sometimes, what if we wanted to do, let's go back to our function for our f of x equals 2 to the x and g of x equals 1 over x. Now, what's f of 0? Well, f of 0 is 1. 2 to 0 is 1. Okay. Any number to the 0 is 1. Put an x equals 0, you go up here, you get the y equals 1. Okay. What's f of g of 1? Or f of g of 0 equals 1. What's the problem with that? What's g of 0?
1.
Show me those figures if you wish. Okay, well, the gesture I like on that is the one we saw the other day. Okay. F of g of 0 would be problematic because we have to start at 0 here, and there's no point on the graph. Because remember, as we go twice as close, we go twice as high. We never get to the y-axis. There's no value for x equals 0. So f of g of 0 undefined since zero is undefined. You can't evaluate f at an undefined number. A number that doesn't exist. Okay. So sometimes you have to restrict the domain. So even though f of x is a nice continuous function forever, f of g of x isn't, because g of x isn't continuous. It doesn't have a value at x equals 0. So the domain of f of g of x would be negative infinity 0, union 0, infinity. And sometimes, not in this case, if you do g of f of x, you got to be careful. G of f of x would be 1 over 2 to the x, wouldn't it? I'll take my word for it if you don't see it immediately. Okay. Well, 2 to the x always has a value. So 1 over 2 to the x always has a value. So g of f of x would be continuous for all values, because any number you put into 2 to the x, if you then put the result in here, it's going to give you non-negative or a defined result. Because these numbers are always positive, and 1 over x is defined for all positive numbers. If you have a square root of g of x, okay, well, g of x can't be negative then. Okay. So if f of x is a square root of root function, g of x couldn't be negative, meaning x couldn't be negative, because if x is negative, 1 over x is negative. Okay, those are the ideas. Composite functions, and no big deal. Okay. So if you have questions, remember, you can always email me.